Good evening to all of you. So first of all, tell me, can you hear me clearly? My voice is clear. Just tell me. Okay, that's all right. So today is our first virtual lecture, and it is our chapter number 1. It is a system of linear equations and matrices. So in this, we will read the following things. First of all, we will discuss an introduction. After that, we will discuss a unique solution. And after that, we will discuss the matrix and how to operate on the matrix and how we can multiply the matrix and how we can find the inverse of the matrix. So these things we will see in today's lecture. So most of the things I discuss in my face-to-face class, but few things maybe it's not clear in your face-to-face class. Now in this PowerPoint slides it will be clear for you. So let's start our first lecture. So as I told you in my face-to-face class, there are several things are there system of linear equations. So for example, if we have two equations, equation number 1, this is our equation number 1, 2x minus y is equal to 1, and this is our equation number 2, 3x plus 2y is equal to 10 is equal to 12. So there are two equations, and if we are going to draw these two equations on a graph paper, so this is the line of the equation number 1, and this is the line of the equation number 2. These are two lines we will draw on the graph paper. So when you draw these two lines on the graph paper, you will find that both these two lines are cut at one point. This point is called the solution of the point, and if you mark on the graph, the coordinates of this point are 2 and 3. So as I told you in my face-to-face class, so there are three methods from that we can solve these two equations, equation number 1 and equation number 2. So our first number is we can solve this equation through the graph, and we can solve this equation through the algebraically method. So here, first of all, we will discuss how we can solve this equation through the graph and how we can get the solutions. So when we solve these two equations, we get the solution that is a unique solution. Yani, these two lines are cut at one point, so that we say that it is a unique solution. So next one is, we discuss the system of two linear equations in two variables. We can say that this is equation number 1, and this is equation number, there are two equations, equation number 1, this is equation number 2, there are two equations a, b, c, and there are a, b, c, d, h, k are real numbers, and a, b, c, d are non-zero. So these are, and the point of intersection on the two straight lines L1, L2 represent by the first, second, and equation. So these all things are written here that I told you. These are the theory. So this is, I told you that this is the unique solution. Whenever the two lines L1, L2 are cut at exactly one point, then we say that it is a unique solution. Here, we observe that the line L1 and the line L2, both of them are cut at one point. So this is called the unique solution at x1, y1. Similarly, next we will see that what happen if we have a two straight lines L1 and L2, one and only one of the following may occur. So what happen if the L1 and L2 are coincident? So if you remember, I told you in my face-to-face class, the meaning of coincident means yani one upper other, yani the two lines are on the same line, yani the L1, this is L1 and this is L2, yani both the lines are on the top or the other. So what happen if the two lines are on the yes, you are right, Khalid. If the two lines are on the same, then the solution is infinitely many solutions, because of they are cut at infinitely many points, and every point they are cutting each other, so these are infinitely many points. So this is the second point. And the third point is when we have a two lines L1 and L2, one and only one of the file, when happen there are two lines L1 and L2 and both are parallel. So in this case they are not cutting anywhere. So we say that what is the solution of these two lines? What we say? They are not cutting each other, so we say that there is no solution because of they are not cutting anywhere. So we say that there is no solution of these two lines. So there are three things we discussed: that unique solution. Hello, now, yes, can you hear me clearly now? Yes, okay. There is a network error maybe. So now we are there. L1 and L2 are parallel. It means that there is no solutions. So there is no solution here because of they are not cutting each other. So three things we discussed: the unique solution, infinitely many solution, and there is no solution. So now we proceed. Let us take an example of these three. So with the help of example, we will understand. Consider there are two equations. This is equation number one, the equation number one of the line, and we take the equation number two of the line. And first of all, we will solve these two equations. As I told you in my face-to-face class, you will draw the box and take the value of x and y. First you take x, and here you take y, and first you take the value of x is equal to 0 and the value of y is equal to 0. And on this way you can solve it, or either you can take the line and multiply the equation number 1 by 2 and cancel it out, and then you will get the value of x is equal to 2. So this is the method you can solve it. So similarly, when you get the value of x is equal to 2, and similarly you can get the value, put the value of x in any one equation, then you can get the value of y is equal to 3. So there is so your solution is 2 and 3. So when you solve these two equations, you will get a point that is a 2 and 3. So tell me which type of this solution is it a unique solution, infinitely solution, or no solution? So which of these it is? Yes, you are right, Adel. It is a unique solution because of we get only 1 point. So that is why we say that it is a unique solution of the system of equation. So similarly, let us on a graph we can draw it like this. It is a unique solution. Here we draw two lines and we observe that it is a unique solution. So either you can solve by the algebraically or you can solve by the graphically, you get the same result. So Let us take any other example. Let us take any other example. Let us take two equations again, equation number 1 and equation number 2. There are two equations, and uh, what you don't understand, Mr. Aladdin? What the thing you are not understand? It's just repeating. I clearly explain on my face-to-face class. If you attend my face-to-face class, over there I told you very clearly that there are three types of solutions. If in a previously I told you that there are three things. One thing is called the unique solution. If we get only one solution, that is called the unique solution. If we get both are parallel lines, then we say there are infinitely many solutions. If we get these two lines, if these two lines are not intersect each other, then we say there are no solution. So similarly, these things we consider in algebraically. In algebraically, we have two lines. If we get one point, then we say that it is a unique solution. We get 1 point only. So that is why we say that unique solution. How to solve the equation? Just you, as I told, yes, this is the equation number 2. This is your equation number 2, and just put the value of x is equal to 2 over here. Then you multiply it, you will get the same number. So it's very easy. If you attend my face-to-face class, then it's very easy. There are two lines. There are two lines. You multiply the equation any equation by 2 or by 3, then they are cutting each other like this. You can cut each other, and you will get this result like this. So it's so simple. So it is a unique solution. So now uh, we now we proceed. A system model it is completed. Now we are on the second point. If we have again we are taking the two lines, line number 1 and line number 2, and just solve them by multiplying. Don't go in this method. Follow that method that I show you in my face-to-face class. So either you multiply the equation number 1 by the 3 or by the 2. So let us we multiply the equation number 1 by 3. So when you multiply equation number 1 by 3, so 3 to the 6 and 3 1 the 3. So that cancel it out and cancel it out. So what you get, 0 is equal to what? 0 is equal to this. So 3 and 2. So you will get 0 and 0. So which is a true statement. So that means we say that there are infinitely many solutions. When you put any equations to anyone, then you say that there are infinitely many solutions. There are any two lines are on the top of the other. So that is, we say that it is, yes, you can multiply any, you can multiply any number, then you get the 3. If you multiply 3 minus, you can multiply minus 3, then it will be cancel it out. Okay, you have to multiply minus 3. It's okay. So next thing is, if next thing, a system of equation has no solution. So again I will take the two equation number 1 and equation number 2. There are two equations, and again I will solve these two equations. So we will multiply any number, like at which number I have to multiply from equation number 1. So I will multiply the equation number 1 by 2 3 the 6. No, I will multiply the equation number 1 by 3, or you can multiply minus 3. So when you multiply minus 3, it will be 6, it will be minus 6, and it will be minus plus 3, it will be plus 3, and it will be minus 3. So just cancel it out and just cancel it out. So you will get 0 is equal to 9. You will get this 0 is equal to 9. So which type of solution it is? So it is clearly impossible. So you say that it is no solution. Okay. So, and if you are going to draw the graph of these two equations, you observe that these two lines are not cutting anywhere. So you say that there is a no solution. Okay. So now we proceed. the same thing we can, if as I told you in my face-to-face class, up to here we are discussing up to 2 by 2. If we have a 2 by 2 matrices, 2 by 2 equations, 2 equations, 2 unknowns. But what happens if you have a 3 equations, 3 unknown, and 4 equations, 4 unknown? So how we can solve these type of things? So there is a method that is called the Gauss elimination method, Gauss-Jordan method. So from that way we can solve these type of equations. So again, let us see. This is a 3 by 3 equations, and first of all we write an augmented matrix. So I will tell you. So these are the rules. You will read these rules clearly. I told you in my I will tell you in the example again, as I told you in my face-to-face class. So I will so these are the rules that we follow. So this is the equations. These are 3 equations we will solve with. So I told you, first of all you have to write the augmented matrix, and then after the augmented matrix you will apply the row operation again and again until it will become a unit matrix. So let us observe how they are also going to solve. First of all, in this PowerPoint slides, first of all they are with your convenience they are showing that how these are going. But after that we are coming on the main topic, as I do in my face-to-face class. So here they are, for your convenience, they are doing like you can understand easily. But I will show you. So so this is the final results. Z is equal to 1, Y is equal to 1, X is equal to 3. So these are, in this PowerPoint slides, they are showing with the same matrices. But I will show you as I solve in my face-to-face class. So like this I show you. So this is our question is given. So I told you, first of all write the coefficient matrix or augmented matrix. So write the coefficient of x is 2, so you write the coefficient of x2 here. The coefficient of x is 3, you write the coefficient of x is 3 here. The coefficient of x is -1, so you write minus here. Again the coefficient of y is 4, you write 4 here. And in the same way you write the right hand side here, and you write the right hand side here. So everything you write. This matrix is called the augmented matrix. Now to solve this augmented matrix, so the steps, as I told you, that our aim is to make this element will be 1 and rest of the element will be 0, 0. This is our aim. This element will be 1 and rest of the element will be 0, 0. And our next aim is this element will be 1 and this element will be 0. And next aim is this element will be 1 and rest of the element will be 0. So this is our aim. We will apply the row operation again and again until we get this type of matrix. And we get like this 1, 0, 0 and 1, 0 and 1, 1, like this type of. We will solve the matrix until we are getting this type of matrix. So we will apply the row operation again and again. So let us see. So they apply the row operation, they will get 1 here and rest of the part is here. Again they will apply the row operation, they will get the 0 in the next step. Again they will apply the row operation, they will get 0, 0 in the first column. Again they will apply the row operation, they will get the second point is 1. Again they will apply the row operation, they will get the 0 upper side. Again they will apply the row operation, they will get the 0 on the lower side. Now again they will apply the row operation, they will get 1 on his on that side. Again they will apply the row operation, they will get the 0. Again they will apply the row operation, they will get this. So finally we get this matrix. So this is our main matrix that we require. So our main solution is zx is equal to x is equal to 3, y is equal to 1, and z is equal to 2. Or here if you observe clearly here, it's z is equal to x is equal to 3, y is equal to 1, and z is equal to 3. So this is called the Gauss elimination method, or you can say Gauss-Jordan method. So by putting it in the row echelon form. So if you observe that in the parallel way, they are solving both the things. If you observe clearly, I'm repeating backside. So they are doing what operation they are applying here in the same way they are applying here. So here, so don't confuse with it. Like here they are applying here, and again here both. So don't confuse with this. The both either you can solve on here, or you can put it on the augmented matrix here. So like here they are applying here, they are, so again and again and again and again. So they will solve this matrix. This is called the augmented matrix, or this is the procedure to solve Gauss elimination, Gauss-Jordan method. So now next we proceed. So these are the rules that you follow. As I told you, first column will be 1, next the rest part is 0. These are the theory, you will read it, the theory. So interchange any two rows, replace any row by non-zero step. So these are the theory, you will read it. All the theory, all the part that I told you, all these things are written here. You will read it clearly. So unit column, all these things are written here. How we can replace, how we can multiply, how we can. But the main thing is that I told you. So these are the operations, R1, RJ, interchange. So all these things I show you in my face-to-face class. How we can add the two row, how we can multiply and add them. These are the things. All the theory is written here. You will read it clearly. So again, let us take an example. With the help of example, you can more understand. So pivot the matrix about the circled element. So they are explaining again how they are doing the how they are making the unit matrix. So we have this matrix, and we want to convert this matrix into the unit matrix. So maybe you can more clearly, you will see. I will share my desktop. Wait a minute. Where is it? This is we are here. We this matrix we have given, and we have to convert it into the unit matrix, pivot the matrix about the circle element. So I want, in place of 3, I want 1. So what we do is we will divide the first row by 3, because of when we divide the first row by 3, that will equal to 1. So we will divide the row 1 by 3, so it will be 1, and the next one will be 5 by 3, and 9 by 3 will be 3, and second row will be same. Now our next aim is, I want, in the place of 2, I want it is 0. So what I did, I apply the row operation R2 minus 2R1. So that I apply this operation, that this will be 0. So when I apply this operation, it will be 0. So our next aim is, I want, in place of minus 1 by 3, I want 1 in this place. So what operation I have to apply over here? So it will get a 0. It will get a 1. So we apply the operation, yani we multiply minus 3 over here. So it will get a 1. So this is our complete result. So similarly, write the augmented matrix corresponding to the linear system of equations. So these are the rules that are written. So there are the system of equations are given here, and we are going to convert it in, we are going to solve it. So first of all, we have to write the augmented matrix. Here we write the augmented matrix, and our first aim is convert first element. It will equal to 1. So what we do, we add row 2 and row 1. If we add these two things, then first row will be 1. So we add these two things, that will become a 1. Now our next aim is, I want a row 2 will be 0. So what we do, if we add row 1 and row 2, so what it will be, now next time is R2 plus 2 times R1, then it will be 0, row 2 will be 0. So, and I also want row 3 will be 0. So I will subtract row 3 by row 1, then it will be 0. So next, it is complete our first aim. Now our next aim is, I want to replace 2 by 1. So what operation I have to apply? So I want this operation, yani row 2, I want in this place, I want 1. So let us do it. I will replace row 2 by row 3, and now I will divide the row 2 by 2. So when I divide row 2 by 2, it will be 1. And now next is, I want in the row 3 there is a 2. I want in that place is a 0. So I will subtract these two things, then it will be 0. So our next aim is, I want to remove 31 from row 3. So I will divide the row 3 by 31. So it will be equal to 1. So it is the if it is approximately complete up to here, so you can find the solutions. But if you want to more solve, then you can further solve it. If you can put in place of 9, you will put the 0. In place of minus 6, you put the 0. So you can proceed further. So it will become a unit matrix here, and there are the 3 solutions are there on the right side. So x is equal to 3, y is equal to 4, and z is equal to 1. So this is called the row echelon form. By the Gauss elimination method, we solve the Gauss elimination method by the Gauss row echelon form. So the solution of the system is thus: x is equal to 3, y is equal to 4, and z is equal to 1. So it is, you will do more practice, you can understand. So there are several examples are there. You will see these examples at your home. So how we can solve like this, there is another example, and they will make a 0 here. Like we have to divide minus 1 by 7, we want 1, and similarly we will divide again, and this is a 0 is equal to 0. So this further we cannot solve. So we observe that the whole row will be 0. So it is the solution of the equation. So there are infinitely many solutions are there. Because of this whole row will be 0, it's we say that there are infinitely many solutions. Similarly, again, there the third example I show you of a no solution. If we have is there are three equations, and first of all we write the augmented matrix. This is the augmented matrix. I write it here, and as usual I will convert it into the row echelon form. So in the row echelon form, the first element will be 1. This is the pivotal element, and the rest of the element in the first column will be 0. So with the help of row operation, I will apply the row operation, row 2 minus 3r1 and row 3 minus r1. With the help of this row operation, that will be 0. And our next aim is I want to remove minus 4, and in place of minus 4 I want 1. So I apply the row operation. With the help of row operation, I will get 0 in the bottom, and I want in the place of minus 4. Here it is, they are not showing, but I in place of minus 4 we will get a 1. So we observe that our third row will be 0, and that element is non-zero. So we say that there is a no solution. Remember that if our whole row, last row will be 0, we say that there are infinitely many solutions. If our this row is 0 and it is not 0, then we say that it is no solution. If our this here is non-zero and here is non-zero, and left side is non-zero and right side is non-zero, then we say it is a unique solution. So in the matrix form, again I told you there are three types of solutions: unique solution, infinitely solution, and there is no solution. So what are the conditions in the matrix? I'm repeating once again. In the matrix, the condition of the condition of the unique solution is the right side will be non-zero and the left side will be non-zero. Then we say it is a unique solution. If we have a right side is 0 and left side is also 0, then we say that there are infinitely many solutions. And in the third case, if we have a left side is 0 and left side is non-zero and right side is 0, then we say that it has a no solution. So we will discuss these things. So there are these three things we discuss: no solution, exactly one solutions, and infinitely many solutions. So now there are some basic things that we discuss. Matrices, how we can add the two matrices, how we can multiply the two matrices, how we can subtract the two matrices. These are the basic things that these are all of you are aware about it. This is just the revision for you. Maybe for example, if we have a two matrix as given, so how we can add them, how we can multiply them. So these are just the revisions for you. There are two matrices are there. Solve the following matrix equation for x, y, and z. So what is the value of x? Do two matrices are equivalent, then what we have to do? We will see that x is equal to 4 and z is equal to 3. If you are going to add and subtract the two matrices, just they are showing that how they are going to add these two matrices. This is a matrix and there is another matrix. Just going to add these two matrices, adding element to element, then you get this addition. Similarly, there in the matrix, the commutative law holds and the associative law are holds. And what is the transpose of the matrix? If you have a matrix is given
and if you are going to find the transpose of this matrix, then you will convert the row into the column. So for example, our first row will be 1 2 3. If you are going to find the transpose, then this row will become the first column, first row will become the first column. Then it says that it is a transpose, and it is denoted by AT. So here you observe that first row will become first column, second row will become the second column, third row will become the third column. So this is called the transpose of the matrix. Similarly, if you are going to find the matrix X that satisfies 2AX plus B, so this is here is a simple question, and it is also just the revision. So just we can solve it like this: 2x is equal to b plus 3a, and you are giving the equation, and 2x is equal to just take on the left right on the right side, and x is equal to like this 2 by 3, and just add them, multiply them, and you will get the matrix x is equal to 1 by 2, and just put 1 by 2 inside, you will get this matrix. So this type of questions you have to know about it. Multiplication of the matrix. If you are going to multiply the two matrix, then the important thing that you have to note that first of all, you have to know what about the row matrix. If we have a row is given, then we say that it is a row matrix. If column is given, then we say that it is a column matrix. And if we are going to product of the two matrix, then we will multiply the row matrix and the column matrix. So find the matrix product. There are two matrices, and we have to multiply these two matrices. So what we did, we will multiply the first element with the first element, and the second element with the second element, and the third element with the third element, with the fourth element with the fourth element. So in this way we can multiply the two matrices. That is called the product of the two matrices. So it is one row, one column. So it's very easy to multiply. What happened if we have two row, two column, three row, three column? So let us we see what happened, how we can multiply the two row and two columns. So if such cases appear, then we have to know that if we have a two matrix A and B, so then you must be attention that if we have a 1 into n matrix and another matrix will be n into 1, then this must be same, and n and n into n must be same. If it is not same, then you cannot multiply these two matrices. And our first, if we have a 3 by 4 matrix and the other matrix will be 4 by 3, then only you can multiply. Otherwise, if there is some other type of thing, then you cannot multiply the two matrix. So we notice that if this type of things happen, then only you can multiply the two matrix. So let us see. There are two matrix. The matrix will be 2 by 3 and 3 by 4. The first matrix will be 2 by 3. 2 means there are two rows, and 3 means there are three columns, 1 2 3. And the another matrix will be three rows, 1 2 3 rows, and 4 columns, 1 2 3 4. There are 4 columns. So we see that the matrix product C is equal to AB is feasible, since the number of columns of A is equal to number of rows on B and has base. So here is same, yani it is a 2 by 3 and it is a 3 by 4, yani both the things are same, 3 and 3 are same. So we say that we can solve this matrix. So these are just the revisions of you how we can. So these are example of two products of the two matrices. So it shows that how we can solve these matrices. First row, first column, second row, second column, like this, 3 1 4. Then the third column, and after that it will take a second row and first column. After that we will take the second row and the second column. After that we will take the second row and the third column. In this way we can multiply, we can find the new matrix. Okay, I'm repeating once again how we'll do. If we have a two matrix, how you can multiply, you will first of all you will find the first element. You have to write the first element by multiplying first row and first column. So when you multiply these two things, you will get the first element. Another time you will get the second element by multiplying the first row and the second column. You will get 24. Another time you will multiply the first row and the third column. You will get -3. And the next time you will multiply the second row, first column, you will get 13. And the next time you will multiply the second row and the second column, you will get 7. And the next time you will multiply the second row and the third column, you will get 10. So in this way we can multiply in the two matrices. So hopefully you understand clearly how we can multiply the two matrices. And there are the identity matrix. If we have a matrix, its diagonal element is 1, then we say that it's the identity matrix. Or we can denote it by I. So the next thing is how we can find the inverse of the square matrix. Inverse means yani A into A inverse is equal to I, yani identity matrix. So for example, a matrix is given, A is equal to, and its inverse is A inverse is equal to this. So when you multiply a matrix with its inverse, so we observe that it will become an identity matrix. So this is the rule of the inverse. So now after that I will show you how we can find the inverse. So either we can find the A into A inverse or multiply A inverse into A, we will get the same result, that is an identity matrix. So there are two methods to find the inverse of the matrix. So first method, this is the first method. It says that you have to reduce the matrix into row echelon form, and whatever you get on the right side, that is called the inverse. So this is the matrix is given, and we write first on the right side there is a unit matrix, and now apply the row echelon form, and apply the row echelon form again and again until we will get the unit matrix on the left side. So here we observe that we get the unit matrix on the left side, and whatever the matrix on the right side, it is called the inverse. So it is called the inverse of A. This is the first method to solve to find the inverse of the matrix. Now if we have a 2 by 2 matrix, so it's very easy to find the inverse. If we have a 2 by 2 matrix, then first of all find the determinant, D. D means AD minus BC. AD minus BC, just multiply. If it is not equal to 0, then we say that its inverse is exists. If it is 0, then you say that its inverse does not exist. So when it is not 0, then its inverse will be, just replace D and A. Just replace D and A and put minus B and minus C here, and that is called the inverse. So it is a one-line method. It in exam maybe this question is asked in a one mark question. So let us see an example. It is a 2 by 2 matrix. Find the inverse of this matrix. So what you do, first of all, you will check whether its determinant is AD minus BC is 0 or not. So when you find AD minus BC is 0 or not, so AD minus BC, it is -2, it is not 0. So you say that yes, its inverse is exist. Now what is the inverse? So you will the inverse, what you do, just replace DA minus B minus C. In this case DA 4 1 and -2 -3. Just replace it, you will get A inverse is equal to 2, 1, 3 by 2 and 1. So it's very easy method to find the inverse of the matrix. So it is the end of your lecture, and there is nothing. So if so now tell me if you have any other questions, then tell me. So hopefully you understand. If you have any questions, then tell me. These slides I will prepare from myself. If you want these slides, then okay, I can give you these slides. Um, uh, I will upload these slides on the Blackboard. Let's wait few days. On up to next Sunday, I will upload these slides on the Blackboard. Um, because of if you see the PowerPoint slides on the Blackboard, by default PowerPoint slides, these are not sufficient. These are very short slides, and in those slides maybe you cannot understand clearly. So that is why I will prepare these slides with myself, and maybe these are helpful for you. So inshallah, I will upload these slides very shortly on the Blackboard. Okay. Okay, welcome, and okay, take care and have a nice day. Goodbye.